All right, so the next section we're covering is 1.6, which deals with subtracting real numbers. And one of the things we need to make sure we are clear about is what an opposite, when we talk about opposite value, what we're talking about. So we're actually going to go to the PowerPoint of 1.5 and just talk about this for a second. Oops, give it back. Oops, let's get to the opposite. We're looking for opposite. Okay. So we're talking about finding the opposite of a number. Okay. And this is kind of the definition. Definition makes it maybe a little bit more complicated than it is. But two numbers that are the same distance from zero but lie on opposite sides of zero are called opposites or additive inverse of each other. Basically, opposite means you just do the opposite of whatever sign it is. So if the number's negative, it's going to become positive. If the number's positive, it becomes negative. So example, what's the opposite of negative 35? You would say positive 35. What's the opposite of positive 12? You would say negative 12. See the difference between opposites and remember our absolute value is different. Absolute value will always be positive, but opposite you always just do you're going to find the different sign. If you look at C, you'll see negative 3 over 11. The opposite of that would be positive 3 over 11. And we don't worry, we don't do much with decimals right now, but 1.9, the opposite of positive, that's a positive 1.9 would be negative 1.9. So we kind of got to mention that because our rule with subtracting and um, some people might have been taught a different way to do this, okay? But we no longer really say subtract when we are subtracting real numbers. We say we are going to add opposites. So in other words, if you had A minus B, you're going to take the A and you're going to add it to the opposite of B. And in this case, B would be positive. So the opposite of positive B would be negative B. So again, that takes me also back to our slide that was in 1.5. So let's go back to our screen. And see if I can get out of here. All right, share screen. So this was the slide that again appeared a couple times. And I told you ignore the subtracting part till we got to 1.6. So again, the subtracting, you're going to change all problems to addition and you add the opposite. So we're not subtracting, we're adding opposites, okay? You're adding opposites. So let's get into some examples. Okay, so we have 23 and we're going to subtract it from negative 2. So again, you go back to the rule, we never change the first number. Okay, so the number before the subtraction sign, nothing's going to happen to that value. So the 23 is going to stay the way it is, but we're going to change the subtraction to addition. Subtraction changes to addition. And again, what are we doing? We are always adding opposites. So we're changing subtraction to addition. And now what is the opposite of negative 2? The opposite of negative 2 is a positive. So we don't have to write plus a plus. Okay, you can just leave that as plus positive 2. And now we go to our rules. Are the signs the same? Yes, they're both positive. So when they're both positive, we add. So 23 plus 2 would be 25. And again, we keep the sign. And in this case, they are both positive. So our answer is a positive 25. Okay, adding, subtraction is adding opposite. You're going to change the subtraction sign to an addition, and then you do the opposite of whatever number is following. Look at another example. All right, remember, we do nothing with the first number. That negative 11 stays a negative 11. This subtraction sign here would turn into a addition sign. And again, the opposite of negative 13, the opposite of negative 13 is a positive 13. So once we change it to an addition problem, it goes back to our addition rules of 1.5. So you're asking yourself, are the signs the same or different? Signs are different, right? One negative, one positive. The signs are different. We subtract. 13 take away 11 would give me a 2. And then the last thing we do is positive or negative 2. Again, we got 11 negatives. We got 13 positives. So what's going to win? Positives are going to win. So our answer would be a positive 2. All right, let's look at another one. All right, so in this case, we have a negative 41 being subtracted by 39. We don't subtract. What do? We add opposites, okay? We don't do anything to the first term. That stays negative 41. We're going to change that subtraction sign to a positive. Now, this is where you really got to be careful. What is a number following the subtraction sign? Okay, what is this number? That is a positive 39, right? So what is the opposite of positive 39? That would be a negative 39. So now we go back to our addition rules. Are the signs the same or different? You'll notice they are the same. So we're going to add those two together. 41 plus 39 would give me a value of 80. But again, since they're both negative, our answer is also negative. Don't tell me negative 41 plus negative 39 would be a positive 80. Nope, that's when we are multiplying. When we are not multiplying, we are adding. The rules when you add, if the signs are the same, you add them and keep the sign. So in other words, if they're both negative, it's going to be a bigger negative. All right, it'd be like you borrowed $41, then you borrowed another $39. How much are you in the hole? We're in the hole $80. A lot of my students, I work at Vanguard and teach a class at CF, but a lot of my students, when I put it in terms of money, they seem to follow along a little bit better. Same thing here. If you borrowed $11, but then you got $13, got to pay back the 11, right? And what are you left with? You'd be left with $2. All right, so once again, these fractions don't go away. So let's do one with the fraction. Let's do one with different denominators. All right, so you're doing negative 1/6 being subtracted by 7/4. I'm going to set it up vertically. And actually, what I want to do before I actually set it up vertically is let's change this to our addition. Remember, so what we do, we don't do anything to the negative 1/6, but we're going to change this subtraction sign to a positive sign. And then that's a positive 7/4 behind it, okay? And what's the opposite of positive 7/4? That would become a negative 7/4. So we're changing negative 1/6 minus 7/4 to negative 1/6 plus negative 7/4. So we are adding then a negative 7/4. One of the things you're going to see a lot, the way I do it, if you see the negative will kind of be in the middle of this fraction here. I will always write it on my numerator. So I will always move that negative up to the top value of the fraction. Okay, so that was kind of like negative 7/4 kind of in the middle. I apply it to the top, to our numerator, all right? So now we got to come up with an LCD of 6 and 24. And I would start with the multiples of 6. We got 6, and then 6 times 2 would be 12, right? So we would use 12. If you did 24, that's fine. You would just have to reduce afterward. But 12 would be our LCD, would be the lowest common denominator. So we got to multiply that by 3. And again, even though we haven't really covered it, negative times a positive is a negative. Sometimes they assume things, and there actually will be a lesson where we'll talk about multiplying positive and negative numbers. But at this point, you kind of have to assume you know that. So now we're looking at, so we keep the denominator of 12. So what we're doing is we're taking -2 and we're adding it to a -21. Okay, so again, we're addition rules. Our signs are the same. They're both negative. So the rule is if the signs are the same, we add 21 and 2, and we're going to get 23. And I keep the sign, and in this case, the sign is negative, so our answer is a -23 over 12. Now, next thing you're going to see is kind of these order of operation problems, where you're going to have to do multiple subtractions and adding of integers. They just kind of really want to make sure you understand what you're doing when you're adding and subtracting these integers. So ideally, since all we have is addition and subtraction, the rule is you do these, whatever comes first, left to right. So in other words, you're going to work from left to right. Okay. One of the first things I would do is just rewrite these problems where we don't have subtraction. We want them all to be addition problems. Okay, so anywhere there's a subtraction, we're going to change it to adding of the opposites. Okay, and we can just do that pretty quickly. So here we have being subtracted by -3, so we're going to change that to adding. What's the opposite of -3? That would become +3. Now we're adding a plus and -1, so I don't have to change anything there. But then right here, you see being subtracted by 7. So I'm going to change this subtraction sign to addition. And the opposite of +7 is -7. I want to kind of review that again, because this is basically everything we got to know with 1.6. -17 being, you know it's subtracted because the first thing you see is a subtraction sign. Where you see following the -3, you see an addition sign. Okay, so we know we're subtracting, and we're subtracting a negative value, so we change the subtraction to addition, and we do the opposite of -3 would make this +3. Since I'm adding here, I don't have to change anything, I'm just moving that information down. But when I come here, you'll see -7. Okay, so that -7, we have to change to a plus -7. Okay, so this is a plus a -7. So what we have here is we have a bunch of addition operations that we have to do. So what we want to do first is just work left to right. Follow your addition rules. -17 plus 3. Signs are different. So we subtract. 17 from 3 gives me 14. Is that +14 or -14? The answer is it's negative because there's much more negative values than there are positives. At this point, I'm just going to move everything else down. Okay, so I solved that and I moved this stuff down. My next step again is left to right. -14 plus -1. Signs the same or different? They're both negative, so they are the same. So I add 14 and 1, that gives me 15, and it'll stay negative, right? You add them and you keep the sign. So now then I just move down the plus -7. So that's the last thing I got to do. And again, signs the same or different? They are the same. If they're the same, we add them and keep the sign. In this case, we would get a negative. So the answer there would be negative 22. A couple more dealing with order of operations. All right, let's be careful here. Oops, move it so you guys can see it. 3 minus 9 plus 3 squared. Always, first thing we do in order of operations is parentheses. So we would have to be doing this. We don't subtract anymore. We don't do 3 take away 9. What we do is we take 3 and we add the opposite of 9, which in this case would be a negative 9. So that's what we have to do first. Our addition rule tells us these signs are different, right? One's positive, one's, so we're subtracting 3 from negative 9. What's 9 take away 3? That gives me a 6. And is it positive or negative? It's going to be negative because there's 9 negatives. There's only 3 positives. There's a lot more negatives. Now be careful here. 3 squared is not 6. So that's the next rule after parentheses is exponent. So we have to do this exponent, which is 3 times 3, which would give me 9. And our last step, we got a negative 6 plus 9. Signs are different. So I subtract 9 from 6 and I get 3. And is the answer positive 3 or negative 3? It'll be positive 3 because there's 9 positives, but there's 6 negatives. So that would be positive 3. Do a couple more examples. Again, be careful with this one. I know we had one, I think, in 1.4. It says subtract a number from negative 42. So again, it's easy. Anytime you see a number, we know we're using the variable. Oops. Subtract a number from negative 42. So anytime we see the term a number, we know we're using a variable. But this is not x minus 42. This is, again, you're subtracting a number from negative 42. So in other words, you are starting with negative 42, and then you're subtracting a number from it. So that is negative 42 minus x. Careful on that. The most common wrong answer is x minus 42 or x minus a negative 42. Remember, you're subtracting a number from. So you're starting with that negative 42 and you're subtracting a number from it. We got a couple more examples. All right, so we had a similar problem already to this, but I wanted to do another one. What I want you to recognize is what are subtractions and what are additions, okay? So what we have is right here, you'll see 1 being take away from 9, that's a subtraction. Then you'll see plus negative 10, so you see the plus sign, so we know we're adding, so I don't have to do anything there. But then I have a minus 7, that's another subtraction, and then a minus 15 is another subtraction, because there should always be a plus sign. That's how we know we're adding. So these are the 3 that we have to change using our adding opposites rule. So 1 minus 9 is going to actually become 1 plus, since it's positive 9, it's going to be 1 plus a negative 9. And I'll try to write my negatives a little higher up so you see we're not really subtraction. So this is plus a negative 10. Now the minus 7 is going to change to a plus a negative 7. And then a minus 15 would change to plus a negative 15. And I kind of just want to stop for 1 second. A lot of the stuff that we do, okay, there's so many different ways you can teach it. So if you were taught a different way, by all means, and you're able to get the answer correct by the way you were taught, then go ahead and stick with that. If the way that I teach it helps you and you're able to get the answer right doing it that way, then go ahead, go to that way. If you find another way, now I'm not exactly sure the way that the MyMathLab teaches it. I think they teach it kind of the same way. I know they do the absolute value and stuff. So again, you might have been taught a different way. than the way I teach it. And if you're comfortable with that and you're getting the answer right, you're probably not even watching this video right now. So again, I'm not telling you my way is the only way. It's just, I always, when I'm presenting this stuff, I present it the way that to me, it's the easiest way. But it's not the only way. I just, stress that. All right, let's get back to this problem. 1 plus a negative 9 plus a negative 10 plus a negative 7 plus a negative 15. So there's a lot going on. But if we work and we follow our order of operations step by step, it's really not that difficult. You just got to do it step by step, one operation at a time. What we have is all additions going on at the same time. So how do I know? Can I start right here? Can I start right here? The rule, order of operation rule, states that we work left to right. Okay, so we got to do these one at a time. And you'll see I won't skip steps. I will solve this and then just move everything else down. So let's talk about, we're doing 1 plus a negative 9. Signs are different. So we subtract 9 from 1. We get 8. And then is it positive 8 or negative 8? It's negative because there's all these negatives. There's only one positive. I write that down. And then again, I just move all this other information down. All right. So again, as I work left to right, what's happening is I'm kind of eliminating a sign each time I do this. I'm eliminating a step. So I'm doing negative 8 plus negative 8 plus negative 10. The signs are the same. So we're adding 8 plus 10 gives me 18. And then is it positive or negative? Since it's negative, they're both negative. We keep the sign of negative. Move everything else down. We'll work here. Negative 18 plus a net, signs again are the same. So 18 plus 7 gives me 25. And again, it stays negative because they're both negative. And I move this down. And it's our last step. But again, they're both negative. So I'm going to add 25 plus 15. 25 plus 15 will give me 40. And again, they stay the same sign. In this case, they stay negative. So again, a recap, we just changed all the subtractions to additions. And then we just kept working left to right, one step at a time. And our last example here for what is this, 1.6. So you have a negative x plus 4 equals negative x minus 9. And you see this little semicolon, and then you'll see the negative 4 off to the side. So basically what they're telling you is x is negative 4. That's all that you really need to know about that. And then it actually will write out is negative 4 a solution of the equation. So again, what you're doing is you're substituting wherever your x value is, you're going to substitute it with negative 4. And so you got to be real careful here. Okay, so I write, so it's a negative and then a parenthesis, and next value. So you write a negative with the parentheses, plus 4. Negative with the parentheses, plus 9. And what value are you substituting in where these parentheses are? We're going to substitute a negative 4 value. This is where you got to be careful. What you have to understand, and again, we're going to talk about more about these double negatives in our next section we cover. But in other words, this is if we're doing a subtracted by negative 4, okay, we would change this to adding the opposite. The opposite of negative 4 would be positive 4. So we have a positive 4 plus 4. What's 4 plus 4? 8. And then again, we're subtracting a negative 4, so that's going to make this a positive 4. Adding the opposite of negative 4 is plus 4. And then you'll see a minus 9, which means we got to change that subtraction sign to a plus a negative 9. If we clean this up a little bit, basically what we're doing on this side is 4 plus negative 9. Signs are different, right? So we subtract 9 from 4 would give me 5. I will make it negative, and they're asking you basically, does 8 equal negative 5? And no, it does not. So again, is negative 4 a solution of that equation? And your answer would be no. No, it is not, because they do not. If they did equal each other, then you would say, yes, they are. So that is 1.5, and I mean, sorry, this is the video we just did is 1.6.